Now that all but the 440 holes are spot drilled, I'll add the drilling cycle to drill the 1/8 NPT tapped holes next. In preparation for the PEC drilling, I've gone ahead and added the tool's starting and ending codes here. Now I'll enter the G83 PEC drilling line. The Z is negative 0.725 because these holes go into the cross holes shown here. Their center is negative 0.625, and I want the holes drilled so the full diameter is flush with the center of the cross holes. Therefore, I need to compensate for the drill tip. For a standard 118-degree included angle drill, the length of the tip is 0.3 times the diameter, which for the 0.332 drill equals 0.0996, which I'll round off to 0.1. By setting the R to 0.05 and using the G99, a small amount of time will be saved per part by not feeding the tool through the extra 50 thou of air from 0.1 to 0.05, and by not retracting the drill to 0.1 after every hole. If this were a high volume production part, that small time savings per part would be significant. The Q 0.15 tells the machine to remove 150 thou material with every peck. Next, I'll call the subprogram with the hole locations. Then I'll refresh the plot and simulate it. So here we see all of our spot drilling. And here we see our PEC drilling. Before I go any further, I want to check the cycle time. So I'm going to come up to Tools and down to Runtime Estimation. And I can see currently the estimated cycle time is 1 minute and 13.3 seconds. I'll close this window. If I was only making a few of these parts, I would not worry about the cycle time. But if this was a production part, the cycle time is critical. I would always start a program using the G83 drilling cycle, as it is the safest because it always retracts the tool out of the hole. After a few parts have been run, I'll change to the G73 cycle if the cutting conditions allow this. If they do not, I would increase the pecking amount as much as possible to decrease the cycle time. I'll change the G83 to 73 and refresh the plot. And then again, I'll simulate the PEC drilling. And now I'll check the cycle time. And I can see the total cycle time is now just shy of 59 seconds. I'll close this window, and I can see changing from G83 to G73 has created a time savings of 14 seconds per part. This time saving is because the G73 does not retract the tool out of the part after every peck, but merely backs up to break the chip and continues drilling. In the next video, I'll do a detailed comparison of G83 and G73.